Dear students, in this lecture, we shall present some problems and its solutions which are very important in exam regarding Heisenberg uncertainty principle. So let's start. Problem 1. Starting from the uncertainty relation delta x delta px greater than equal to h line by 2, obtain number 1 delta phi delta jz greater than equal to h line by 2, and second delta E delta T greater than equal to h line by 2. Given delta x delta px greater than equal to h line by 2, here we divided delta x by r and multiply delta px with r. So we may write delta x by r into delta px greater than equal to h line by 2. Now delta x by r is equal to delta phi and r into delta px equal to delta jz. So delta phi into delta jz greater than equal to h line by 2. Let's understand how is it possible. Look at the diagram. Suppose a particle revolves round a circular track of radius r. When the angular position of this particle is phi, the linear position is x, then the angular position phi equal to x by r. So the uncertainty in measurement of angular position is equal to delta x by r because r is constant, and as the particle is in the xy plane, so angular momentum will be in the direction of z, and we may write the angular momentum along z direction jz equal to rpx. The uncertainty in measurement of this angular momentum is equal to r into delta px. Then it is clear that delta x by r equal to delta phi and r into delta px equal to delta jz. So it is proved. Given delta x delta px greater than equal to h line by 2 or delta x m into delta vx greater than equal to h line by 2, as we know delta px equal to m delta vx. Delta Vx is the uncertainty in measurement of velocity of the particle along x direction, or we may write delta x into m delta Vx square by delta Vx greater than equal to h line by 2, or delta x into delta E by delta x by delta t greater than equal to h line by 2, as delta Vx equal to delta x by delta t and delta E equal to m delta Vx square. This is the uncertainty in measurement of energy, or delta E into delta t greater than equal to h line by 2, and it is proved. Number 2. Using Heisenberg uncertainty principle, obtain the ground state of energy of a linear harmonic oscillator having total energy Et equal to px square by 2m plus half m omega square x square, and assume to confined in a region of width a. Given Et equal to px square by 2m plus half m omega square x square. Now if delta x and delta px are the uncertainties in determining the position and momentum of the oscillator, then we may write the total energy as Et equal to delta px square by 2m plus half m omega square delta x square. From Heisenberg uncertainty principle, we may write delta x into delta px equal to h line by 2, or delta px equal to h line by 2 delta x. Putting the values of delta px in this relation, we may write Et equal to h line square by 2m into 2 delta x square plus half m omega square delta x square. and this is equal to h line square by 8m delta x square plus half m omega square delta x square. As by question, the oscillator confined in a region of width a, so the uncertainty in position measurement along x-axis is equal to a. So we may write by question delta x equal to a. Now we replace delta x by a and we get et equal to h line square by 8m a square plus half m omega square a square. Actually, the ground state energy of linear harmonic oscillator is the minimum energy of that oscillator. So we may write for ground state energy, that is Et equal to E minimum, the first integral of Et with respect to A must be equal to 0. From this relation we get minus h line square by 4m a cube plus m omega square a equal to 0. Putting this value in this equation, we get the minimum energy as half h line omega, and this is the ground state energy of the linear harmonic oscillator, or a square equal to h line by 2m omega. Putting this value in this equation, we get the minimum energy as half h line omega, and this is the ground state energy of the linear harmonic oscillator. Problem 3. An electron is confined in a box of length 10 to the power minus 9 meter. Calculate the minimum uncertainty of its velocity. Solution. From Heisenberg uncertainty principle, delta x delta px equal to h line by 2. Now if delta x is maximum, then delta px must be minimum, so we may write delta x max into delta px mean equal to h line by 2, or delta x max into m delta vx mean equal to h line by 2. This delta vx is the uncertainty in measurement of velocity. Putting the values of h line, mass of the electron, and the position uncertainty of the electron, we get delta vx mean equal to 5.763 into 10 to the power 4 meter per second. The electronic mass is equal to 9.11 into 10 to the power minus 31 kg, and h line equal to 1.05 into 10 to the power minus 34 joule second. So this is the minimum uncertainty of the velocity of the electron.